Welcome to the class on syntax directed translation. Till now we have seen some grammar, and for the grammar we have given some parser. Now but in practice, whenever we go for any compiler design, we will associate with grammar informal notations, also known as semantic rules. So for example, syntax directed translation for evaluation of expression would be something like grammar plus semantic rules. So whenever I say grammar plus semantic rules, that is grammar plus semantic rules, this is nothing but syntax directed translation. So we are going to see the topic of syntax directed translation in detail. So let's say for SDT for syntax directed translation for expression. So expression means the operators plus and star and so on, right? So let's say the parsing would be, let's say the grammar is E equal to E plus T, and the appropriate action for this would be, let's say, E dot well is equal to E dot well plus T dot well, right? And for T, it will be E dot well is equal to T dot well. Then we are having T is equal to T star F, right? So T star F. So T dot well is equal to T dot well star F dot well, and or F, this will be or F. So this is T dot well is equal to F dot well value, right? And F is having some number associated with it. So F dot well is equal to num dot L well, number dot L well. I request all of you to note down this small SDT, and then we will go ahead with the other issues related to it. So what we have seen till now is compiler is not only plain grammar, but along with that grammar, no, we give some meaningful rules so that syntax analysis as well as many other things like code generation, storing of some values in the symbol table, intermediate code generation, or even expression evaluation. That is, many things can be done in parallel at the same time when the parsing is being done. Therefore, parsers are capable of doing more when grammar is associated with semantic actions. So how to carry out SDTs on expression is first derive the parse tree for it, and then we need to we need to traverse this tree from the top to bottom and then left to right. So let us take the example of the expression, let's say 2 into 2 plus 3 into 4. So what we will do is, using this, we'll be preparing one the parse tree for this. Okay, let us see how the parse tree will be prepared, and then we will evaluate it. So this is an expression 2 plus 3 star 4, and what will be the parse tree for this would be E dot, let's say E equal to E plus T. So E equal to E plus T, and we know that this T is equal to T star F, right? So this T is equal to T star and F, right? So this is the, then it gives you E tends to T, and then T tends to F, and F tends to number, right? So this is how your parse tree would be. Then T tends to F, and F tends to number. Then F tends to number. right? And we know that numbers are 2, 3, and 4. So what we will do is we will associate with these attributes the number is 2, 3, and 4, right? So what we have done is number is nothing but the token, and 2, 3, 4 are the lexical values, right? And lexical value means what does this number actually mean? That is nothing but the actual value is equal to the lexical value, right? So after generating the parse tree, we will be traversing it top to bottom and left to right. So what will be the situation is, let's say I told you to note down the previous SDT. So it will top to bottom, understand, top to bottom and left to right. So this is how the traversal is going to take place, right? And what will happen is after generating the parse tree, we are going to do this traversal, right? So whenever there is a reduction, we go to the production and carry out the action, right? So whenever there is a reduction, we have to carry out the action. So here f tends to number. So f tends to number is nothing but we are associating f dot value attribute with the value is equal to 2, right? So this is how the reduction is going to take place. So whenever there is a reduction, we go to the production and carry out the action. So in SDT, every variable is going to get one or more attribute for some time, and it might get even 0 attribute also. It depends upon the type of SDT we are talking about, right? So every variable I'm talking is going to get an attribute in this SDT, and it is not necessary that in every SDT we should get it, right? So let us continue. And what is going to happen is t tends to f, right? So t dot value is equal to f dot value. So again, it will be getting the same value from the bottom, and then e dot value equal to e tends to t, right? So e dot value equal to again 2, right? So it will continue, and here there is no reduction, right? So it will continue from top to bottom, left to right. Again there is a reduction, so f dot value equal to 3 will continue to t dot value equal to 3. This value will be passed on to the top level, and then still there is no reduction, so it will continue in this way. And f dot value equal to what? Equal to the value which is num dot l value, which is 4, right? So 4 will be passed here, and here that what is going to happen is there is a reduction. T tends to t star f. So what is t star f? T tends to t star f, right? So this was the production, and t dot, the action was t dot well is equal to t dot well star f dot well. So to just to keep it different, I'm saying it t1, right? Just for making it little different. So this is t1 dot well, right? So 3 into 4 is 12. So t dot well here equal to 12, and then this will continue. And here again there is a reduction. So e equal to e plus t. So e equal to e plus t, there was e dot well equal to e dot well plus t dot well. So that is 2 plus 12 is e dot well equal to evaluated to 14. So answer comes to 14 in this case, right? So are you getting? So we have, what we have done is we have done the traversal from top to bottom and left to right. And for every reduction, it keeps on transforming the values to the appropriate productions at the top level, and finally it will reach to the start where the actual expression is evaluated. So we have seen one SDT for evaluation of an expression, right? So now what we will do is we'll take another example, and we'll see how to convert the infix expression to the postfix expression, right? So we'll see infix to postfix SDT. Okay, so what will be the SDT for this? Let's say e tends to e plus t, and what I will do is I will just say printf. What will be the action is? Action is printf, and I'm saying just plus. Okay, that's it. Then e tends to t, I'm saying don't do anything. Action is nothing, right? And t tends to t star f, I'm saying print star, right? So printf star. Okay, and t tends to f. I'm saying don't do anything. F tends to number. So what it should do is print the number, right? So print f number. Right, so you just have to print that number dot lvel. I'm saying the attribute would, for that would be num dot lvel, right? So you print that number dot lvel with percentage d option, maybe percentage d and something, right? So that number would be printed. Now semicolon is there and then finish. Okay, so this is the simple plain SDT for infix to postfix expression conversion. Now what we have to do is we have to derive the pass tree, and from the pass tree again, no, we have to see that whether there are two approaches that is possible for this. Two approaches are top down approach and the bottom up approach, right? So these two approaches, we'll check with the same example with both the approaches to get what is the result that we get from this. Please note down this SDT for infix to postfix expression, and then we will see the conversion for using the pass tree, the further steps. Okay, so okay, there was you should have noted here printf plus. You can just say it is 1. Then there was nothing here, so that was 2. Then printf star, which was 3. Then nothing here, that was 4. I'm just numbering it. And printf lvel, number dot lvel. So this is 5. So in that way, there were 5 steps which were there. And after noting down these 5 steps, these 5 steps we'll be using, so that in the pass tree, so that it becomes easy for us to understand. I forgot that before. For that. Okay, so E tends to E plus T. E tends to E plus T. And I said it was at 1. So I'm noting down that 1 also. Okay. Then what is possible is E tends to T. E tends to T, and that was at level 2, right? So that was 2. Then T tends to F, and the action was E tends to F, which was action was 4, right? So I'm noting down 4. Okay. Then F tends to number. F tends to number was there, and this was, I think, was 5, right? So in this way, I'm just writing down the steps at which the action is going to be, the semantic action is going to be performed. Let's say T tends to T star F, right? So T tends to T star F, and this was at which level? It was at level 3. So I will also note down the level 3 for this. Okay. Then T tends to F. We know that this is T tends to F, and it was at level 4. And F tends to number, which was at level 5. Right. So I'm just noting down in this way. This is I'm talking of. See, it is top-down approach. Top-down parsing approach. What we have done is we have just put up everything. Again, this is F tends to number, and this was at level 5. Okay. So now we know that these numbers are nothing but 2. This is number nothing but 2. Then this is 3, and this was 4. Right. So we are still into the equation of what was that? Was 2 plus 3 into 4. Right. So we want to convert this infix expression to postfix. So what will happen now? So we know that top-down parsing, we always start with the derive the pass tree from the start symbol and keep the productions as it is, and to place in place of the semantic actions, what I'm putting here is I'm putting the numbers, right? And I'm then traversing the pass tree from top down and left to right. So whenever I encounter any semantic actions like 1, 2, 3, 4, and 5, I'm just performing that semantic action. I'm going to perform that semantic action, right? So let us see what the things would be done. So it will start from here, and whenever it sees the semantic action, so where is the semantic action? Semantic action is coming up here, 5. So what was there at 5? It was saying print the number. So it is just printing the number. Let's say this is the 2, which is getting printed. Print num.lol, right? And then it will continue, right? So what was 4? 4 was saying it was nothing, right? Then again it will continue and it will come to 2. So what is that 2? 2 was E tends to 2 was what? Again 2 was nothing, right? So it will continue in that way, and still there is no action. So it will go here. It will go to the next action. So that is coming to 5. So what is that 5? It is saying printf num.lval. So what it will do is it will print the value 3, right? So again we know that 4 is nothing, so it will continue. Then it will continue here and wait for the next action. So that is 5. So again what it will do is 3, 2, 3, 4. So 4 it will get printed. Then it will go here. Then 3. What was 3? 3 was, it was star, right? So printf star. So star would be printed. And so printing of this star is done here by 3. It will continue here, come back here. What was 1? It was saying printf plus. So it is printing plus. And then it is returning to the end, right, to the star. So what we actually got is, we got the string which is printed, and that is the postfix notation, right? Okay, so this, what we have done is we have just seen the top-down parsing approach. Now we'll see the same example with the help of bottom-up parsing. And mainly in the bottom-up parsing, what we do is we normally focus on the semantic actions. Semantic actions as far as the reduction is concerned. Whenever there is a reduction, we will perform this reduction operation, and we'll come to that solution for that. Okay, so in the bottom-up parsing, we are interested in the reduction operation. So wherever there is a reduction, it is going to do the operation, right? So what will be the case is, let's say E equal to E plus T, and this is E tends to T, T tends to F, F tends to number, and this was E, T tends to T star, and F, T tends to F, F tends to number, and F tends to number. So here that was 2, 3, and 4. And whenever there is we have seen this, right, bottom of parsing. So whenever there is a reduction operation, reduction is taking place here, F tends to number. So F dot well equal to num dot well, that is 2. And it will go on in this way. So 2, T dot well equal to 2. Here in this case, the value is not forwarded in this way, but instead it is saying that it is supposed to take the action, which is nothing but print action, right? So it will do what? F number, it will print the number 2 here, right? Then it will continue. It will continue here, and then it is null. Then it will print this 3. Then it is null. Then this number 4 is printed, and then this number will be, that star is getting printed here, and it is then plus is printed. So at this level there is plus which is going to be printed, right? So in this way, the infix to postfix expression is also going to give you the same result. So we got the same output. So SDTs can be used both by bottom up as well as by the top down. And difference is when are we going to carry out these actions, right? So difference is when we are going to carry out the action, depending upon whether it is at the reduction level or wherever, or maybe when there is a top-down approach. In the top-down approach, we are going to see the semantic actions 1, 2, 3, 4, and 5 in that way. So only normal parsers they are able to do a lot of other things also.